Ma'am, 1 minute, I'll introduce you.
Okay.
Good afternoon, everyone. This is Supriya, your host for the day. And it's my privilege to welcome you all to the 170th episode of Creative Weekend Talks. Creative is registered trust dedicated to knowledge sharing and building constructive thinking across various domains. Guided by our tagline, Knowledge Square, sharing knowledge increases our knowledge. We explore topics behind conventional academics to expand our understanding of the world around us. Our weekend talks are conducted every Saturday from 3 to 4 p.m. on Zoom, and also we live stream on our YouTube channel Creative GBD, ensuring a wider reach for meaningful discussion. Today's session focus on comets, celestial bodies that have captivating scientists and astronomers for centuries. They provide valuable insights into the early solar system and continue to be a subject of significant research. We are honored to have Dr. Shailaja B.S. Ma'am as our distinguished guest speaker with her expertise in astronomy. She will provide us with a deeper understanding of comets, their origin, and their significance in space science. So, I welcome you, ma'am, and I welcome all the participants. And I invite Uma Devi, creative volunteer, to introduce today's speaker. Over to Uma Devi.
Thank you, ma'am. A very good afternoon to everyone present here with warm greetings. It is indeed a great pleasure to extend a warm welcome on behalf of Creative team conducting wonderful webinar on Comets, the Mysterious Visitors by a resource person, Dr. B.S. Shailaja ma'am, visiting scientist, Jawaharlal Nehru Planetarium, Bangalore. Ma'am has obtained her MSc in Physics from the Bangalore University and PhD from the Indian Institute of Astrophysics, working on Wood-Rayet's binary stars. Ma'am has joined the Jawaharlal Nehru Planetarium as educator in 1994. She has been involved in the preparation of planetarium programs. She initiated teaching astronomy at different levels with 5-day and 3-day workshops called Universe in the Classroom and Introduction to the Night Sky for students, teachers, and laypersons. With great geniality, she initiated the monthly Skywatch program called Know Your Stars, which is conducted on the first Sunday of every month from the year 2000 onwards. Under the aegis of REAP for BSc students, which was formalized in 2000, she taught basics of astronomy and astrophysics till her retirement in 2017. Many interesting students' projects on astronomy were guided by her. Her monthly Skywatch column is running since August 1999. Our ecstatic guest became the senior scientist officer, then deputy director, and took charge as director in 2012. With the enthusiastic support from all the colleagues and local talent, the first attempt to produce an in-house planetarium program was successful. She got several new installations in the science park like the parallel globe, Janta Mantar replicas, and the anti-gravity cottage. Her subjects of interest includes comets, peculiar stars, and Norway. She has more than 120 publications in referred journals and 17 books. She has keen interest in history of astronomy. She is currently working on stone inscriptions, translation and analysis of manuscripts of 17th century and astronomical aspects of temples, monuments, and artworks. Cheers to you, ma'am, and once again welcome you, ma'am. I extend my welcome to all the curious minds gathered here. welcome you all. Over to you, ma'am.
Thank you, Uma Devi. Over to you, ma'am.
Thank you. May I share the screen? Thank you for the nice introduction. It's nice talking to physics teachers. And thank you for inviting me for this forum.
Yes, ma'am.
You are able to see the screen, I think.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So today I want to talk about the comets, the mysterious visitors, because currently it was in news. In October there was a comet. Only here in South India we were not able to see because it was cloudy. But people all over the world enjoyed the scene with naked eye. Similarly, last week also there was a comet, and people in Australia and South Africa, they enjoyed it. Unfortunately for us, it was cloudy, and moreover, it was very low in the south. So maybe people from Kanyakumari would have seen it, but for the rain. So why do these comets come and go? This kind of a question will arise. So I start with some historical records. This is a very old painting of a comet, and this is a very famous painting. And this was done by an artist called Giotto. This is the painting of the Christmas three saints coming and visiting. And the story goes that they were guided by something in the sky, a star. So he felt that it should be a comet, and because just then he had seen a comet, one of the apparitions of Comet Halley, and that he recorded in this painting. So the European Space Agency sent a mission to Comet Halley, and it was named as Giotto. And then comets were known to be bringing some calamities and bad luck and things like that. So these are the paintings that are connected with that. And it seems at the time of Nero also there was a comet. And once upon a time, sometime in the 16th century, there were two comets. So the painting depicts that it brought famine and people died. So they all attributed it to comets, and comets were considered to be bad omens and something unwanted. That was the attitude they had. And it gradually we came to know that I will explain how it all happened. So it was Tycho Brahe who was trying to prepare the orbit of the comet. And this is his drawing wherein he tried to put it into in comparison with other planets. And he thought that this fitted almost into an orbit, some kind of a thing. And for that, he had to make sure that this is not something that is happening in our own atmosphere. Because some people thought that this is a phenomena happening inside our own atmosphere. So he conducted some experiment to establish that it is beyond the Earth's atmosphere at a distance much more than that of Mercury and Venus. So that's a very classic experiment he did, positioning two people at two different places and actually measuring what we today call as parallax. So, so they belong to a region which is not very far from the moon or a little beyond the moon. This is the understanding he got. Then he tried transformation of coordinates. This is a very crucial step because you see something in the sky and the drawings that you see in the textbooks are all depictions. No, I see somebody writing something on the screen. I don't know how it happens. Somebody is writing something on my screen. How is it possible?
Ma'am, it's annotation. We have an option in upside, ma'am. We can off this annotation. Can you do it, ma'am?
I don't know. You please do it. I don't know. I will
It's
exit and.
no, ma'am. It's okay. Continue. It's option come for you only. We can't do anything. Who shares the screen, they have the option. You continue. No problem.
Okay, because this is by mistake or mischief, I don't know.
Okay, ma'am.
Okay, because this will continue in all the slides now.
You
unless,
can. Yes, ma'am. You
unless
can.
that person removes it himself, isn't it?
Yes, ma'am.
Okay, let me see how. Otherwise, I will exit and share
Yes,
this.
ma'am. Yes, ma'am. Once again,
I'll
you can
stop
share.
sharing.
Ma'am, while sharing, you have to do a disable annotation you have to give, that's all.
One
There will be
option
three
comes.
dots, you press it and then it will come. Disable annotation, you do it, nobody can do it then.
Where is disable notation?
Upside, ma'am, there is one column.
Okay.
Three dots.
There will be three dots. Are you seeing three dots?
No, I
One
have now
corner.
gone to share. I have to gone to share the screen. And no, 1 minute. Before that itself, I have to do, is it?
Yes, ma'am. No,
Where
ma'am,
are-
after sharing.
After
After
Request
share.
all participants to maintain some decency, okay? Please don't do it.
Now you are back on the
Yes,
screen?
ma'am. Yes,
Huh?
ma'am.
Okay. So transformation of coordinates is something that we do with computers now. Effectively, it means that something you see in the sky and then you transfer it onto paper into 2 dimensions. And that is how you are able to get some meaning for the movement of the planets. Okay. So he thought, look at this picture, he thought that the comets are moving in straight lines. So this is a very interesting observation. And he was puzzled as to how can something be moving in a straight line in the sky. And then, of course, other people worked out. Before I go to that, I have to tell you something about the nomenclature. If you look at the names of the comets, they are all assigned with the names of the discoverers. Charles Messier, he was known as the Comet Man. He was, those days they were giving prizes for discovering comets, and so he got the maximum number of prizes. Similarly, Bernard, who was a very poor fellow, he with his little money, he managed to buy a telescope, and he would see the moving spot before anybody spotted and announce that he has discovered a comet, and he became a very rich person. This was the state of affairs 200 years ago. And the only Indian who has the credit of discovery of a comet is M.K. Venubapu, who was my guide for PhD also. He established the Indian Institute of Astrophysics in Koramangala in Bangalore. And of course, nowadays you hear comet names like Shoemaker, Levy. Shoemaker, Levy was a very grand team, they observed. But of late, you see acronyms like this, Linear, ISON, and so on. These are all automated systems which track any body that is moving in the sky. And Linear 1, Linear 2, Atlas, the one which was discovered recently, both of them were called Atlas. There are all groups of telescopes established in different parts of the globe. So if one object sees something which is moving with respect to the stars, it immediately alerts the other telescopes. They track it and establish that this is a comet. And therefore now amateur astronomers and naked eye observers do not have much chance to discover comets. I should also mention about there were discoveries from India in the 19th century. This was by John Taylor from the Madras Observatory. Those days, the communication would reach England by ship. So by the time he announced it and it reached the Royal Society, somebody else had already seen it and the credit did not go to him. There is another case also. This is from Thiruvananthapuram. This is Subramanya Iyer. He also discovered a comet in 1941. So sorry again, somebody is writing something. I don't know. Where are the 3 dots which I should say?
Upside one, 3 dots, one column will come, ma'am.
Yes.
There you click on that.
Huh?
You can see the disable annotation.
Disable. Ask to start video. Hide non-video for participants. Report. View profile. Something is coming. Anyway, that person removed it. So let me continue.
Okay.
Okay. So. This is from the Thiruvananthapuram Observatory, which is still existing. If you go to Thiruvananthapuram, you can see this observatory still. It was established by Swati Tirunal. You would have heard his name as a musician, music composer. He was greatly interested in astronomy and he had made some observations himself. He was very, very well versed with astronomical observations. So he established his observatory with the help of another person called Cal Dot. and it is surviving even now. The dome is still there, the building is still there. So when you go to Trivandrum, please see this. There, this person, Subramanya Iyer, was the director. He observed this comet, he discovered it, and he also chalked out some details on it. But by the time he reported it, he was late. So this is brought out in a publication. His efforts have been brought out. And this is a small video I have given as youtube.com, that link, which tells you this episode, the whole episode of how Swati Tirunal established the observatory and how the comet discovery was missed out and so on. We made a series of videos in the 75th year of independence called miscellaneous things, such interesting things which come out of astronomical records. So this is one of them. So now let me get back to the discovery and the nomenclature. So Leonard was one of the recent ones which is named after an individual. So he discovered it in 2021 and it is called A1. That means it was the first comet to be discovered in the month of January. So the second half of January, if something is getting discovered, it becomes A2 and so on. That's the way it is named. And the name will be that of person who first reports it. Well, Halley did not discover the comet, but his name is associated with it because he made a lot of calculations and he was the one who established that they also are part of the solar system and they have highly elliptical orbits. Shoemaker-Levy, and this was a very famous comet in the year, it was discovered in the year 1993. It, some two arrows have come again. Please don't distract me by putting such things. The other animation that you are seeing for Comet Leonard shows the orbit, the speciality of the orbit. The vertical bars represent its elevation from the plane of the ecliptic. That is, the ecliptic is a plane which is containing the sun and the earth. So it comes from above the plane, crosses the sun and goes below the plane. So that is the speciality of this. Generally, we think that all the comets are all the planets are in the plane of the solar system, whereas comets can come from any direction. The animation here for the other one shows the same 4 planets in a small scale. Then you have, you're all physics people, so you know this. So the conic sections can be the planetary orbits. So the comets can have either elliptical orbits or parabolic orbits or hyperbolic orbits. And the eccentricity is very high. And Newton made an attempt to understand the comets. And now this is the reason why there is a wrong belief that it is it's moving in straight line. Now you see this is an elliptical orbit or a parabolic orbit. If you make observations only here, you are seeing M, N, O, P, Q, R, S. Then it can be a straight line, it can be a parabola, it can be a hyperbola, but definitely not a circle, not an ellipse of the order of eccentricity of the planets. So this is the reason why people mistook that they're all moving in straight lines. But it was the effort of Halley which established it very correctly. And so he had a long debate. He was a contemporary of Isaac Newton. So they had a long discussion on the possible path. And by then Kepler's laws were already established. And Tycho Brahe gave a suggestion that it could be a parabolic path. And then he started sketching the path of the comet and looked at the similarity of the apparitions in 1531, 1607, and 1682. And then he found that it must be going. So this is what he declared. Hence, I dare venture to foretell that it will return again in the year 1758. This is what he said. Okay, some distraction is still there. I'm sorry. I'm not able to concentrate because there are so many.
Please turn off that annotation, ma'am. I can't do as an admin.
I don't know how to do that.
Once again, you share the screen, ma'am.
I did share. Okay.
Upside there will be 3 dots.
Yes.
Okay,
Disable. Okay.
ma'am. Nobody can do anything now.
Okay.
Continue, ma'am.
Now, where did it go? Where is my screen? Okay.
It's
Now
visible, ma'am.
okay. Okay. No, I have to remove this. Okay. So this is what he declared. I dare venture to foretell that it will return again in the year 1758. He didn't live. He died in 1742. But then the comet reappeared exactly on the date he had predicted, and therefore it is considered great that he was the first one to establish the periodicity of the comets, and so the name of the comet itself became Comet Halley. He did not discover it, he did not even see it, perhaps. And then you have the speciality in the sense that they can be inclined. See, it is so much inclined to the plane of the ecliptic, and some of them can be retrograde in the sense that generally we see all the planets moving from west to east, whereas this can be from east to west also. It can be from south to north. So different kinds of orbits are present. And all these observations led to the idea of understanding what is the source of the comets. So here we have the comet Atlas, which came last month. Now you see that its path is always in the southern hemisphere. That is how we didn't get these vertical lines here. They indicate that it is below the plane of the ecliptic. So it came and just around the perihelion, it was slightly better for us. We should have seen it, but unfortunately we didn't. Now it is back into the southern skies. Only people in Australia, they were able to enjoy it. Okay. Now the orbital parameters, I think you know this for any elliptical orbit, this is the thing, so I can as well skip this. So you have short period comets, long period comets, sun grazers, and now you have what are called interstellar comets and dark comets. So the name itself tells you what is the meaning of this. Halley, which comes in once in 76 years, is considered a short period comets because there are comets with periods of 10,000 years also. And these sun grazers are very interesting. They go very close to the sun, almost into the coronal region of the sun. And most of them do not survive after that. They get instantaneously evaporated by the proximity of the sun. So interstellar comets, by their orbit, we feel that they were not part of the solar system, but they came from outside the solar system. And the latest is these dark comets. So they don't have tail, but they show other properties of the comets. And they're not very bright. So what are they? This is a new thing that has emerged now in the last 2 years. So this is the best example for the interstellar comet. And its name is Oumuamua. That is the name. And this was considered to be an interstellar comet. Now they think that it is also a dark comet. It has no tail. The ones which have tail have two types of tail. One is called the gas tail and the other is called the dust tail. See, the gas tail is the yellow one here. You notice that it is slightly curved and both the tails always point away from the sun. And the length of the tail increases as it goes closer to the sun. You all know the reason, because the matter that is getting evaporated is pushed away by the sun. That is how it happens. And then you have the ions. The ions exactly lying behind this because the solar wind trims them in that direction, whereas you have the dust tail lagging behind because it's still hanging on to the orbit. It tries to be in the orbit itself, but the wind is pushing, so this is an effect of both of them. So when it comes closer and closer to the sun, you can see the distinction very clearly. And any photograph of a comet will show them depending on its distance and the amount of matter that is present in the tail. So you have the nucleus, which is like a rock when it is far away near the aphelion point. As it comes closer and closer, material evaporates at about a distance of, no, it starts even before that, at a distance of about 5 astronomical units itself, we'll start seeing it as a fuzzy patch. It will not look like a point object, but it will have something, which is called as the coma around it. Already the material is evaporating. And as it comes closer and closer, you will see more and more material getting evaporated, and you have a plasma tail. And if it is strong enough or going closer enough, you can actually see the sodium ions getting separated from the hydrogen ions. So you'll have a yellow tail, you have a white tail of the gas, and you have a blue tail of ionized hydrogen. So that is the distinction here. And now the mystery of the anti-tail. Anti-tail, now you see, this is the head, this is the tail, but there is something below it. And it was a matter of great discussion for a long time till they found out that it is an effect of the projection. Now, are you able to see this, what I'm holding? Let's say that this is the tail of the comet and the head is here on this side. Now, let's consider this portion. When you see in different orientations, this part becomes part of this. But if it is like this, if it is like this or like this, at some orientation, you will see it below the head. That is the effect that you are seeing there. So it is nothing strange. That means our perception of the tail view is different. And because it moves in a direction which is perpendicular, almost perpendicular to the plane of the ecliptic, these kinds of different orientations are possible. Okay, so here is what I mentioned about the third tail. This is the comet Neowise, which appeared in 2020. You can clearly see that there are so many different types of tails, and they were able to do some processing, identify sodium and hydrogen ions separately. And this is Catalina. Now you can see that we are seeing it from a different perspective. So if this is the head of the comet, we are seeing it like this. So we are able to see the extension in both directions. And it's interesting that the solar wind was discovered by the comets. So they started observing the comets, and the first question was, why is the tail always away from the sun? And this was analyzed in the 1950s, and they said that there is something pushing them in that direction, and therefore you are able to see them always are pointing away, and that is how the solar wind was discovered. Subsequently, they were able to relate the length of the tail to the activity on the surface of the sun. So the tail is an indirect measure of the activity of the sun. This way also comets are very interesting to observe. We cannot, now we have all these satellites which observe the sun 24 hours. But otherwise, it's very difficult to make out how the sun is behaving. We have many solar observatories, we have many different techniques of observing the sun. But before that, they try to use the comets themselves as an indicator of the activity of the sun. This is another thing, Yarkovsky drift. Now the comets also rotate. So there was a puzzle in the case of Halley and Encke. Halley would, you predict the timings and then you find out that time of perihelion, when exactly it goes to the perihelion point. In case of comet Halley, it always reached the perihelion a few hours before the predicted time. And there is another comet called NK, which would always reach the perihelion 3 hours late. Why is this happening? This was because it had something to do with the rotation. So you have it rotating, depending on whether it is rotating clockwise or anti-clockwise. As it approaches the sun, the material that is coming out. Now here in this diagram, it is explained in the context of asteroid. It's more true for the comets because there the outgassing is predominant. So they provide some kind of a recoil, which if it is in the direction of the rotation, it favors it. If it is in the direction opposite to that of the rotation, it tries to pull it back. That is how the time of reaching the perihelion gets delayed or advanced. Now, what is the escape velocity? So if you have, you all know this formula, I don't have to explain. If you were to do this for a comet, it turns out to be a very small number. That is the reason why so much of outgassing is possible, and the material that is ejected from the comet will not return to it at all. So what is the idea of the mass? How do you get the mass of the comet? So this was one of the points that was used to estimate the mass of the comet. So the material which escapes is gone from the comet forever. That material will never go back to the comet, but it has some velocity. It leaves the comet forever, but then it cannot leave that orbit. So it continues to hover in the orbit. How do we know that it continues to stay in the orbit? It may be moving, it may be settled in the same orbit. Okay, this is a spectroscopy of comets. You know what is spectroscopy and you know what are absorption lines and emission lines, so I don't have to explain. So this is the solar spectrum. So you expect that just as any planet is reflecting the sunlight, comet also should be shining by reflected sunlight. So if you take the spectrum of the comet, you should see somewhat similar lines of hydrogen, sodium, etc. But unusually that is not the thing. So this is the spectrum of a typical comet. You see all the lines in emission. What are these lines? They are molecules of CN, C3, CH, NH2, and oxygen, and so on. So that means the material that is ejected from the comet is dominating the spectrum rather than the light reflected from the sun. So this is the clue to understand what is contained in the comet. And why should these show up only when they are closer to the sun, when they come out? The fact that they're showing that they are in emission means that they are the molecules which are receiving the ultraviolet rays from the sun and then re-emitting them in the visible. So the comet is made up of something which is lying concealed inside, somehow cemented, and once it comes closer to the sun, they are able to escape and they will start showing their presence in the form of the spectrum. So you have frozen gas containing carbon monoxide, carbon dioxide, water, ammonia, alcohol, HCN, and many more. And they also have these dust particles like diamond, graphite, silicon carbide, titanium carbide, silicon nitride. All these materials also are present. We know about this from many space missions that went close to the comet. But what we observe from the Earth is only the spectrum. And so we knew that so many organic molecules are present in the comet. And this is the list of molecules that are present, and its percentage relative to water is given. Plenty of water is noticeable in comet, so much that people have now started believing that The water on the earth was provided by so many comets which came and plunged onto the earth in the early time of the formation of the earth itself. And in 1910, when comet Halley came, just then the presence of cyanogen was discovered. And so cyanogen, as we all know, is something we are afraid of. So when they found that comet is bringing cyanogen, then people started moving around with the umbrella. So this is a cartoon. And they had made some tablets also. They were selling comet tablets, saying that if you take this, nothing will happen to you because of the comet. And this is all the funny part of the apparition in 1910. And there are, as you know, there are two types of water molecules. The ratio of the two, the ortho and para, that is important in determining and comparing it with what we have on the earth today and what was perhaps provided by the comets, whether it was ortho or para, in case how much of it was provided, and what were the environment. So this is a matter of a detailed study now, the two different types of water molecules. I think you can make out the difference, only the spin direction here. That's the difference between the two. So what could be the temperature? Now this has something to do with temperature. Comets are not very hot bodies. Their temperature could be something like the room temperature we have here, 25, 26 degrees Celsius. Based on the orbital specialities, they have conjectured two types of storehouses. The first one is called Kuiper belt, which is just beyond the orbit of Neptune. This was first hypothesized by Kuiper, so it is called the Kuiper belt. And in the same year, considering the long period comets and their orbits which go above and below the plane of the ecliptic, it was conjectured. Wood was the one who conjectured that they are like a sphere, envelope, spherically distributed like an envelope around the solar system, quite far. There is a lot of gap here. So they're all spread out here. And so you have two different species of comets, the Kuiper belt comets and the ones from the Oort cloud. So and then we had space missions in 1985. Again, Halley was the leader there because the comet's apparition was very well known. They had planned a spaceship, not one but four. 4 space missions were targeted to go near Halley, and one of them I mentioned earlier was named Giotto by the European Space Agency. And Russia sent 2 of them. So all these went close to the comet and tried to study. This kind of a thing is not that easy for other comets, although we see them quite often, because by the time you discover and by the time it comes to the perihelion, you are left with a few months. So it's not time to plan a space mission to target them. However, many other things I will just mention. So this was one of the space missions that went close to the Halley. And we had one called Deep Space One, which went to Comet Borrelly. This was in 2001. And this is the shape of the original nucleus. We are not able to see the original nucleus when it comes close to the sun because the material that is outgassing envelopes it like a piece of cotton. So it looks like a piece of cotton. We are not able to see the interior. So this is Deep Space One. And there was this Stardust comet which visited a comet called Will 2. And so it was able to map the body. As you can see, they're all shaped like very odd. They're not spherical at all. And the basic requirement for a spherical body is that there should be enough gravitational force to have them spherical and then provide some kind of a differentiation. That is how we distinguish planets from other bodies today. And we also had Deep Impact, which visited the temple in 2005. So it provided an opportunity to see what happens when something is impacted and how much of material is outgassing from it. And deep impact. It visited comet Hartley also. Now, this is one shape that is of relevance here, because why do the comets break so easily? Suppose you have a ground nut and you want to break the ground nut. You just apply a torque, then it opens up. It's something similar. A small difference in the gravitational force between the two ends of the body is sufficient to break it up. So the comets break very easily, and even the one which came last week, it was given the title as headless comet because the head broke into pieces. Now, what happens to the pieces? The pieces will survive. They continue in the same orbit, and it may so happen that after some whatever period it had, so many years it will come, not as one but two different comets. It did happen in the last decade of 19th century. People were expecting to see a comet which had a period of 7 years or 8 years, but instead of one, they saw two. And then it further broke into pieces, and subsequently they saw that there was no comet at all. But then how did they find out that it broke into pieces? That's interesting. I'll tell later. So this was Churyumov-Gerasimenko, which comes once in 12 years. So in 2014, they planned the mission. And then, because it was a long journey, they had kept this Rosetta in sleep mode. And they woke it up a few years ago, and it was a great event all over Europe, Waking Up Rosetta. That was the name given. So they tried to tell people how important it is. And the interesting thing is they put a lander onto this comet to find out what is happening on the surface of the comet. So these are the close-up views of the comet. So, okay, this is the first picture of comet Halley. This only goes to tell that they have different shapes, different sizes. They rotate, and the rate of rotation and the rate of sublimation, etc., is all different for different comets. So each comet is unique in this sense. You cannot apply what you had derived for one comet to the other comet. The year 1950 is an important year because that is when they proposed that it's Whipple was the person who proposed that it is a dirty snowball. Why is it dirty? Because it's not just plain ice or water that is present there. You have all these different organic molecules that are present inside it. And so the theory was that they are perpetually frozen in the outer solar system. Once in a while, they come inside the solar system. That means they were formed long ago along with the solar system, and they moved in the outermost regions of the solar system, and they have settled there. This is one argument which was put forward. And this was proposed as the dirty snowball model, which is accepted even today. In the same year, Kuiper suggested that there are two types of comets. So he conjectured the Kuiper belt zone. And in the same year, Oort proposed the Oort cloud. That is why 1950 is a very important year in the study of, in understanding the comets. So we understood the structure of the comet with the help of the dirty snowball model. And every time you get a comet and you get more and more observations done, you can verify some finer details of this particular model, especially the interaction with the solar wind. And this is the tidal force. Tidal force we all understand with respect to the sun, earth, moon system. It's the same thing that is applicable for the comets also. As I mentioned, a small torque will be sufficient. Now this is how a particular comet in 2013 broke into pieces, and see, in about 3 months, it was gone. It was not to be seen at all. So they believed that the comet disintegrated, Sorry, these kinds of things, pop-ups distract me. I was trying to recollect the name of the comet. Okay. No, Shoemaker Levy was a very interesting thing. Shoemaker's husband-wife team and David Levy, all the three of them together discovered this. And what they found was that the comet was in the shape of a cigar. It did not have a tail, but the shape of the comet itself was elongated. Then they found that it is all broken into many, many pieces. They were able to identify 21 pieces. It had got its orbit perturbed because of its close approach to planet Jupiter. And after one round, in the second round, it spiraled inwards and went and crashed onto Jupiter. This happened in 1994. And this became a very important turning point because till then it was only some kind of a hypothesis that they break into pieces and they can impact. But we were able to witness this. So this is a photo taken from the Kavlur Observatory, and Hubble Space Telescope took a lot of images, but the impact, Jupiter was like this, the impact happened from the other side, we were seeing from the opposite side. So we had to wait till Jupiter turned to us and we could see the scars. And all these calculations were done very precisely. They were able to pinpoint the individual dots. And this is the shadow of one of the satellites. These are these dots and the scars of the impact. Okay, now this is Giotto flying through this, and so it provided a detailed map of the comet Halley and how outgassing is dependent on the surface features. Okay, this is the other possibility. Now I told you that they break into pieces. This was the one which appeared in the year 1882, and I told you that they expected one comet, but two of them came together. And subsequently, in the next apparition, after 6 years, they wanted to see the two comets again, but it did not come. But they had a meteor shower. That is when they were able to link the comets and the meteor shower. Meteors happen every day. Every night, if the sky is clear, you will definitely see a couple of streaks in the sky. Something from outer space entering the Earth's atmosphere and getting burned. That is meteor. So you see a streak of light. But sometimes you will see hundreds of them. And that is called a shower. The shower is related to the comet. This was established only in the year 1887 or so. And this was the comet which gave clue to that. So, okay, this is the escape velocity calculation. So, you know, the mass of the Earth is 10 to the power 24, and radius of the Earth also, you know. So you get the escape velocity to be some 11 kilometers per second. So in case of comet, what would be the escape velocity? It turns out to be a very small number. Suppose you are left on the comet, you can walk and escape from it. It's as small as that. And that's the reason why these fragments are separated forever from the body of the comet. So now you have a comet which is going around here and it breaks into pieces. The pieces continue in the orbit. They are all spread along the orbit and more in this region because it's here that they get an opportunity to break into pieces. Now this is the orbit of Earth. So the Earth goes to the near the orbit, either here or both. For example, in case of comet Halley, it reaches the Earth very close to the orbit, both in the month of October and in May. At that time, these particles which are loosely moving in the orbit of the comet are attracted to the Earth and they come and fall on the Earth. That is how you have so many, they are small dust particles. So they come and fall on the Earth, and so you have very a very strong flow of things happening in the sky. You can predict the time also when Earth is closest to this orbit, and so you have the cometary dust falling on the Earth as meteors. So this is the reason for the meteor shower. So this is the shower, and the timing of the shower can be precisely calculated. And the person who is now, you can be anywhere on the earth, you can be anywhere on the earth, but the person who has the dawn for that time will see more number of showers, whereas the person who is at the night, he is in this side. So the showers can be coming from all directions, but they are coming only from one particular direction in the sky. So depending on that, so that could be in the direction of a particular constellation, and the shower is named after that. For example, every year November we have Leonids. They all seem to come from the constellation of Leo. See, they can come from anywhere, but like the railway tracks, which although they are parallel, it appears to give us a feeling that they are meeting somewhere in the infinity, something similar to that. And that point in the sky is called the radiant of the meteor shower. So we have several meteor showers. The best example is Leonids in November. The other is in August, Perseids. And in the month of January, we had Quadrantids, and we have Aquarids in the month of May, and so on. So they all define in which direction of the sky they seem to come from. So this is the way it happens. So it appears to come from some particular directions. That is a radiant. So this is for the comet Halley. You have Orionids and Aquarids. Aquarids in the month of May. Orionids in the month of so this is in the month of October. This is in the month of May. And it's not true for all comets. For example, for the comet Swift-Tuttle, you have only one opportunity for the Earth to go near it. The Earth may not go near the other side because the orbit is not favorable for the other point, may be quite far. So this is how it appears. And they have been able to detect it by radio techniques also, because this streak of light which is burning in the air temporarily ionizes the air molecules there, and that will reflect the light rays. So in the olden days, when we had all transmission done by ionospheric reflection, there used to be some strange noises coming now and then. That was because of this meteor. So they would hear that noise, some kind of a noise, and count. So this you can do in the daytime also. So they were able to count how many meteors are falling on the earth, and you should be able to distinguish that from the regular radio transmitting signals, because these will appear only as noise. It's a technique which is used even today. There are ham radio receivers who do this experiment whenever there is a shower. They will count how many particles. So that way they are able to make out that even the dust particles within the orbit, they are clustered here and there, and they are also moving slowly. So this year, compared to the last year's shower, there is a small difference, let's say, of about 15 minutes. So in 15 minutes, the corresponding distance there has been the motion of the clump of dust which is collected there. So this is how they are able to do a lot of indirect calculations with the help of the comet. And okay, this I've already explained. This is the Oort cloud and this is the Kuiper belt. And this is the same thing. So you see that the Kuiper belt is only up to here, but the Oort cloud extends to almost half the distance of the nearby star. Suppose we discover a new comet on an orbit that brings it closer to the sun than Mercury on 25 years. So what can we conclude? It has been on its current orbit for only a very short time compared to the age of our solar system. Or it has a coma and a tail during most of its orbit. It came from the Oort cloud, or it came from the Kuiper belt, or none of the above. Now, these are the kinds of things that provokes us to understand the comet. Now we need to observe the comet closely to answer any of these questions. Now, how does the comet die? I give 4 specific examples. One is comet NK. Comet NK is the shortest period comet we have. It keeps coming into the inner side of the solar system once in, say, 3 years or something. It's a very short period comet. If you see it through the telescope, you barely can make out that it is a comet. It has no tail at all. So what does it mean? It means that this nucleus is good enough to hold itself, but all the material which ought to have been present in that to produce the tail is gone. So it will continue like that for I don't know how many more years, millions of years or something. So it may continue like this forever. Then we have the example of comet Kiyosaki, which appeared in the year 1964 or 65. Apparently, it had a very long tail of about 45 degrees. It covered half the sky. So people who had seen that will always remember that as the comet. Any other thing that you show today, they will not be happy at all, because that was the best comet that ever people get to see with naked eye. And what about that? It may not come back at all because it was in the parabolic orbit. Then you have the example of comet Lovejoy and Ison, which came recently in the last 10 years. They went close to the sun, and just as you are seeing here, it went close to the corona region and evaporated. It's gone. So there is no comet alive at all. And then you have the example of comet Shoemaker-Levy, which crashed onto Jupiter. So there are so many ways in which the death of the comet can occur. So that is comet NK. Even if you take a very good photograph, you can barely make out that it is a comet. It has no tail at all. And this is the comet Kiyosaki. As you can see, it is one of the paintings which shows almost 45 degrees. It was visible to the naked eye. Now, I mentioned about dark comets. So they were observing an object which is named 2003 RM. 2003 is the year of discovery. RM is the number given as per the date of discovery, which month and which fortnight of the month. So they believed it to be an asteroid. And then they were studying the orbit of that. And there was a small deviation which could not be explained at all, except by a small acceleration due to the Arkovsky effect, which I mentioned earlier, only because of the difference in the spin. And generally, we see that only in comets. So this gave the idea that there can be dark comets. This asteroid 2003 RM is barely visible. It's a very dark comet. Its power of reflection also is gone. Then you have a small group of only 7 members. This category was done only in 2023, and now they have been able to identify 7 members belonging to this group. And interestingly, some of them are in an orbit which takes them closer than Mercury to the Sun. In spite of that, they are not very bright. These comets have, therefore, everything to do with the origin of the solar system. They are believed to have been remnants of the material which were pushed out at the time of the formation of the solar system. So we now see that all these organic molecules and other things which they are bringing in were probably accumulated or accreted by the cloud long ago, 5 billion years ago. Now we have a job to find out how those things were formed 5 billion years ago. So the source of water on Earth, this is another interesting thing why we have to study. Now this is Rosetta. Rosetta is one I mentioned about a space mission which went close to the comet Hartley, and then you have Churyumov-Gerasimenko. So this is the photograph it supplied, and some kind of fractal-like structures are there. So which shows that probably the ice things are all uniformly distributed on the surface of the comet. And this is the image of comet Hadley, which shows both the types of para and ortho water, heavy water and normal water, both being present there. So if the comets have supplied all of them to the Earth now, we now know how much of water we have on the Earth. So what was responsible for that? That we should be able to calculate backwards. That means how many comets should have been there in the past, and so on. And the other interesting thing is there is a theory. This theory has a nickname. It is called the Shiva hypothesis. This has everything to do with the sudden impact of number of comets. The solar system is moving in the galaxy in a path. So now it is slightly below the plane of the galaxy. So after some 60 million years or so, it will move into the plane of galaxy, at which time you will encounter lot of dust entering the solar system. All of them will behave like comets, those bodies, and then suddenly you will see a lot more number of comets per year than we are seeing today. Did this happen at all? So this is the question. And this kind of a passage, a periodic passage, which takes it into the plane of into the disk of the Milky Way and below the disk of the Milky Way, is the one which is responsible for a sudden flow, a sudden influx of comets into the inner solar system. And that may be beneficial, that may not be beneficial. It may be beneficial because it must have supplied a lot of comets plus water onto the Earth. It may not be beneficial because heavier of them can impact on the Earth and then create dinosaur disaster. They may wipe out the life on the Earth. Both are possible. In any case, it is something unusual. And this periodicity is about 60 million years, and they call it the Shiva hypothesis, saying that it is similar to the Shiva Tandava Nritya, which is very periodic, and then, compared to the size and time scale of the universe, you can say that it is a dance of the cosmos. So, I have tried to briefly tell you what are these comets and where they are generally found. I also told how they die, and perhaps I was able to impress upon you on why do we need to study them. All said and done, it's a beautiful sight in the sky. If you get an opportunity to see something like this is Pleiades cluster, Kritika, and the comet style is passing through that. It is something very great. So it's a beautiful sight in the sky, and therefore you will never miss a chance to see them. The moment you hear about it, make an effort to go out and see, because it's an once in lifetime sight that you are going to see and enjoy. That way I envy the people in Australia who got beautiful sight of this comet last week and the week before that. And even in October, people in North India and Europe and Canada, they all had a very beautiful view of the comet. Naked eye, just go and stand in the balcony, you could see the comet there. But unfortunately, on both occasions, we were not blessed. But whenever there is a news about it, don't miss. But at the same time, remember that it's not easy to spot them unless you make an effort. So first you have to identify a star, and then identify that a planet is different from a star. And then there is a comet which is different from both of them. So let's hope we will get an opportunity to see a beautiful comet in the coming years. Okay, so thank you for the patience. I think I have conveyed what I wanted to say. Thank you.
Thank you, ma'am. It's a very informative session. Yeah, quickly, any questions, you can unmute and ask the questions directly, or you can type in chat box. Any questions?
Madam, Srinath here.
Yes, sure. Nice to meet you.
Because you
Okay.
mentioned about Madras Observatory and one researcher, but I also wanted to, because I have read your book, Ranganatha Achari book.
Okay.
Raghunatha I'm sorry, Raghunatha I think Raghunatha was instrumental in eclipse-related campaign.
Yes.
Did he also looked at any of the comets? Because you
No.
mentioned.
No, he served as an assistant in the observatory, and I think during his tenure there were no bright comets. The person who observed the comet was Jacob, some 50 years before him. Okay, and he did not live to see the later comets. I think he passed away before the other comets came in the last part of the 19th century. Even if he has observed the comets, it would be in the logbook.
Yeah.
It is a routine observation of the comets. It may only the position. Spectroscopy was not yet developed to the scale of observing the comets those days, at least in Madras Observatory.
Thank you, madam.
And something flashed and vanished. I couldn't read it. Was that a question?
No, ma'am.
Something flashed on the screen, and before I could read it, went off. You please
Just,
see in the chat box if there are any. Please tell me.
no, ma'am. Just the telling very interesting and informative presentation.
Okay.
Stay.
Hello,
Yes.
Madam. I'm Sobha. Can I speak?
Yeah.
Yes, ma'am. Please.
Thank you, Madam. It was very interesting. Just many things which I had not known about that comet and all. It's very well explained, Madam. Just one small, clarification. The outgoing gas or fluid or dust, whatever it is, from that comet.
Yes.
How does it account for the particular comet? All does all the dust or all the gases are same for all the comet, or anything different depending upon the composition? Or
Now I showed you a typical spectrum.
okay,
Typical
yeah,
spectrum had generally all of them will have carbon, all of them will have cyanogen, all of
okay,
them will have water, they will have oxygen also. Generally,
right, yes,
ammonia,
yes,
of course,
yes,
plenty of
yeah,
these. But
yeah,
then the relative ratios of them can vary from comet to comet.
okay.
So
Why does that variation, Madam? It's because comet means
can
comet.
be it can be for different reasons.
Ah,
One is suppose a comet has been coming and going. It's a periodic comet. Then
okay.
it would have lost most of its evaporable
Oh,
material.
okay.
So the
Oh,
quantity itself reduces.
oh,
Okay.
okay.
And as you can imagine, hydrogen is the easiest. So
Yes.
no comet will show any hydrogen line at all. Whatever comet, whatever hydrogen it had is
Oh,
all gone in
evaporated.
the form of carbon. And what we
Oh,
see now are only the organic material,
oh,
water. We have the spectrum shows water.
oh, okay.
Okay.
Yes. Thank you. Thank you so much, Madam. Thank you.
Okay. Any more questions? Okay. I think no more question, and we are running out of time, ma'am.
Okay.
We
Thank
can.
you.
We
Thank you
can.
for the patience. I suppose it was.
A very
It makes you read the physics part of the comets much more keenly. Okay, because you're all physics people basically. A lot of physics is there.
Thank you, ma'am. Thank you very much.
Thank you. Thank you all for the patience.
Thank you, Anandal, for joining.
Madam, sorry, one question is there. Is it possible to discover the comets without telescope? It's interesting. Somebody has posed that question.
I told you how the discoveries were made in the.
Yeah, I know. But now, yes, now can we see without telescope?
No, now the advantage of the telescope, especially the automated telescope systems, not one telescope, group of telescopes like the Neowise or Atlas, they're all there to see any object that is moving with respect to stars, they can detect much easily than what you can do with your naked eye. In the olden days, they used to take a photograph and then take another photograph 3 hours later, compare the two dot by dot, and then find that one particular dot has changed this position. Then go back to that region, take one more photo, then you get 3 positions. You put that in that determinant equation and solve for the orbit. This was the exercise which would take 2 to 3 days or maybe 2 weeks, something like that. Now, all that is now automatic. All that is done automatically. And therefore, all these telescopes, they're able to easily detect a moving dot in the sky. It could be a piece from a discarded piece from a spacecraft also. So the telescope sees even that as a moving object, and then it has to do that automatic comparison with the list of objects that are there as the debris, and that debris part will be also listed, and so they know that okay, this is this debris, so discarded. That's not a comet. Then they have the list of asteroids. So whether it is a known asteroid, discard it. Then they will, if it is an object which is outside these two lists, then they will send it to all the other telescopes. They will automatically track it. Once you start tracking it, you will know whether it is a comet or a near-Earth asteroid, an asteroid coming close to the Earth. So either way, you have an opportunity to discover that. Now, where is the chance for a human there when the computer is doing everything? Right. Now, you observe a dot today, and in order to establish that it is a comet and not a planet or not a star, you wait till 24 hours. Tomorrow, you see the position would have changed. Within 24 hours, these automated systems would have generated all the material about it. So nowadays, it's very rare that humans are discovering the things. Otherwise, was a naked eye affair 400 years ago. 200 years ago, people used to do with binoculars and small telescopes. And 100 years ago, large telescopes would do it. And even 50 years ago, before the advent of space missions. But now we have such a sophisticated system to track a small moving object in the sky. And so it's
Madam, just since this discussion started, Shailaja, with your permission, just I would like to draw the attention of listeners. If you look at, suppose the comet is very nearby Sun, within the perihelios, there are certain Sun observatories which are in the
Soho.
either Lagrange, Soho, SDO. They have
Soho
pointed
has
out those.
discovered 2,000 comets. Because some
Yes.
comets which are so faint, you hardly get a chance to see it unless it goes very close to the sun. When it is so close to the sun, person on the earth can see it because the glare of the sun. But SOHO can see it. SOHO is the solar and heliospheric observatory, which is kept at the Lagrangian point. And hereafter, Aditya also may be able to discover. So you observe that, and so it is a small exercise for people interested in this. So you have to, Soho keeps generating images periodically. Every day, so many images are available in real time. So you compare them. So they release the images online, and people can just compare and discover comets. So that way, there are so many 2,000 comets have been discovered from Soho. And those comets are all for namesake. That means they went near the sun and they were lost. They did not come back at all because they went so close to the sun that they all evaporated instantaneously. So that is another way the comets are discovered by people. Humans are discovering them. But what is the source? The source is a space mission. So maybe Aditya will also give such images, and even high school children then will do that as a game and then start discovering comets. That will be very interesting.
Thank you, madam. Thank you so much.
Thank you,
Yeah,
ma'am.
thanks, Rina, for reminding me about that. I forgot it.
Okay. Okay, we can wind up here, ma'am.